Here is the thing nobody tells you about coding with AI. It has no memory of the last time it burned you. You fix a bug on Monday. On Thursday, a fresh session walks straight back into it, just as confident. Most people answer that by writing a longer prompt, and that does not work, because a rule that lives in a prompt is only a suggestion. Over the next few minutes, I am going to build the thing that does work on one machine with no cloud and no API bill. And I am going to show you every piece of it. Let me be specific about what forgetting costs, because it is not one bug. It is the same correction over and over in slightly different words. You say the tag is missing. It agrees, apologizes, fixes it. 4 minutes gone. Next week, same file, same missing tag, same apology. Nothing is wrong with the model. It answered well both times. The problem is that the second conversation had no way to know the first one ever happened. Nothing wrote it down, so nothing could hand it back. Before I explain the loop, watch it. Same model, Llama 3.2, 3 billion parameters running locally on the processor. Same prompt, same temperature, same retry budget. 3 folders. The only difference between them is what is inside. The first has nothing. The second has a rule but no way to recall anything. The third has the whole loop. Same question to all 3. Watch what comes back, because the middle one is the surprise and it is the setup almost everybody actually has. So here is the shape of it. 4 steps. Detect, something notices a mistake. Capture, that something gets written down without you deciding to. Learn, it gets handed back before the model answers next time. Automation, the whole thing runs whether or not you remember it exists. Miss anyone and the loop is dead. Detect with no capture is a system that scolds you and forgets. Capture with no learn is a diary. Learn with no automation is a thing you have to remember to do, which means you will not. Start with detect because it is the smallest piece and it is the one people get wrong. A detector is not a description of a rule. It is not a paragraph in a prompt asking nicely. A detector is code that runs, looks at one specific thing, and can return a failure. If it can only ever say yes, it is not a detector, it is decoration. The test is simple. Can it stop something from happening? If the answer is no, you have written a comment. Let me write one in front of you because the first one is always smaller than people expect. My rule is that every new source file names the layer it belongs to on its first line. So the detector is a regular expression that matches that shape and 3 lines that decide what to do. Read the first line. If it matches, exit 0. If it does not, print what was expected, print what was found, and exit 2. That is the whole detector. 9 lines. The important line is the last one, because a non-zero exit is what stops the write. Now, where does it run? This is the part that decides whether the detector matters at all. If you run it by hand, you will run it twice and never again. So it goes in front of the tool on the hook that fires before a write lands. The model asks to write the file, the hook runs first, the detector says no, and the write never happens. Not a warning after the fact, a refusal before. That distinction is the entire difference between a detector and a linter you ignore. Detect is working, so now the mistake needs to survive the session. This is capture, and the rule here is that you are not allowed to be part of it. Every refusal and every pass appends 1 row by itself on the event. Not because you decided it was interesting. You will not decide. You will be mid-task, annoyed, and you will move on, which is exactly how the last 4 months of lessons were lost. The machine writes the row because the machine was there and you were busy. Here is what 1 row actually contains and the fields matter. What class of signal it was. The signature of it hashed. The file it happened in. What the tool was trying to do. What the outcome was, refused or passed. And when? 6 fields, 1 line of JSON appended to a Q file. Nothing is interpreted yet. Nothing is judged. That is deliberate because judging at capture time is how you end up capturing only the things that already fit what you believe. That hash field is doing more work than it looks. It is a checksum of the signal class and the signal signature together. If the same thing happens again next Tuesday, it hashes the same, and the queue recognizes it instead of storing it twice. So a recurring problem does not become 40 near identical rows you have to read. It becomes 1 row with a count on it, and that count is itself information. Something that has now happened 5 times is a different priority from something that happened once. Now the step that was missing when I first tried to explain this, and it is the one that turns a pile of rows into knowledge. The queue gets classified. Every candidate gets exactly 1 of 4 verdicts. Discard, this was noise. Promote, this is a real lesson, write it up. Merge, we already know this, fold it into what exists. Defer, this might matter, ask the operator. Most rows are discard, and that is healthy. A queue where everything is a lesson is a queue nobody is reading. So what does a promoted lesson actually look like? 4 parts, and skipping any of them is how you get a knowledge base that nobody uses. The pattern, what happened in plain language. The mechanic, why it happened, the actual cause and not the symptom. The rule, what to do differently, stated so a machine could check it. And the receipts, the file, the run, the number, so a reader in 6 months can verify it instead of trusting it. Pattern, mechanic, rule, receipts. Let me build one from a real failure, one that happened while making this video. A repair step in the pipeline had a branch for when there was nothing to repair, and that branch returned without writing its output file. Pattern, 3 later stages measured a film that was 2 hours old. Mechanic, a stage that produces no output leaves the previous run's file in place. Rule, a stage promises its output, and nothing to do is never permission to skip producing it. Receipts, the run log, and the timestamp that gave it away. Notice what that entry is not. It is not the error message. It is not a stack trace pasted into a file. Anyone can store an error. The value is entirely in the mechanic and the rule because those are the parts that transfer. The next time something has a nothing to do branch, that lesson applies, and the file it was found in does not matter at all. A knowledge base full of error messages is a log. A knowledge base full of mechanics is a system that gets better. So the lessons are written. That is a diary, and a diary is not learning. The difference is retrieval. On every prompt, before the model answers, something reads the task, looks in the knowledge base, and pulls back the entries that apply. Nobody types a reminder. Nobody remembers to check. It runs on the prompt, which is the only time it can possibly help, because after the answer, the mistake has already been made. But how does it choose? There are hundreds of these now, and handing back all of them is the same as handing back none. So retrieval matches on what the task touches. The files named in it, the layer they belong to, the words in the request. Then it takes the top few by score, not the top 40. 2 good lessons attached to a prompt change the answer. 20 lessons attached to a prompt is just a longer prompt, and we already know what those are worth. Which brings us to automation and the honest measure of it. Every layer of the system gets 1 row and 4 columns. Does it detect? Does it capture? Does it learn? Does it automate? Green only if you have watched it fire. Not if it is written down, not if it exists in a file, only if you have seen it work. Right now that is 12 fully green, 10 partial, 15 red out of 37. Red is not a failure report. Red is the build list. That honesty is load-bearing, so let me say why. The temptation is to mark a layer green because you wired it and it looked right. Every time I have done that, the thing was dead and reported success for weeks. So the rule is that a cell goes green when it has refused something, or captured something, or handed something back, and you watched it happen. A registry of intentions tells you nothing. A registry of things you have seen fire tells you exactly what to build next. One more piece and it starts to matter once you have a few hundred lessons. Retrieval by keyword starts guessing. So the whole repository gets turned into a graph, rebuilt on every commit, and the lessons attached to places in that graph rather than to file names. GraphiQuest is that graph in 3 dimensions, and it is worth looking at for one specific reason. The shape of a code base is information, and a list cannot show you a shape. What routes through what nothing has touched in a year. So that is the loop. Detect, capture, learn, automate. Start with 1 detector and 1 lesson. Not the framework, not 37 layers, 1 rule that can refuse and 1 thing it taught you. Wire the capture so you are not in the loop, and the retrieval so nobody has to remember. It is small at the start, and then it compounds, because every failure after that makes the next one less likely. The setup document is below, and it stands the whole thing up inside your own repository. If this helped, hit like so it reaches the next person building one of these. Subscribe and you will get the next build. And tell me in the comments what your first detector caught.